The basic goal of this module is to learn how to write computer programs. So, what is a computer program and why should you care? A computer program is a set of text files that contain statements, instructions for the computer to perform. So we can tell the computer to print something to the screen, to calculate some complicated calculation, to download a file, to change the contents of a file, etc. And then we can type the commands, the statements in the computer programming language that we want the computer to perform. And the computer will then execute this file and perform all the steps that we provide. So a computer program is nothing but a set of instructions for the computer. But these instructions contain a somewhat complicated structure. So rather than take step A, step B, step C, we often have conditions. If this is the case, then do this. If that is the case, do that. Or we have functions that if we many times want to do the same kind of manipulation, the same kind of steps, then we group those steps together. And then we can call the function, and then all these steps will be taken. So functions I will explain next week. So a computer program is just a set of instructions for the computer to execute. So when would this be useful? And especially, of course, in the social sciences, because that is what this course is about. So I can think of a number of examples that we can think of. One example is just a very mundane task that you have to repeat a lot of times. For example, for a research project a few years ago, I wanted to analyze speeches by the Russian president. So there's a website by the Kremlin where all the speeches by the Russian president are uploaded. And you can go there, you can look at the list of uploaded files, you can copy and paste them and download them. And usually they display just a fixed number at a time, maybe 10, 20 at a time. So you can download those, click on the next 20, download those, click on the next 20, download those, etc. Now, the Russian president has uploaded about 8,000 of those events. So he has been president for a long time, and any kind of press conference, meeting with a foreign leader, opening some new building somewhere in Russia, every time there's a little speech, every time the speech is uploaded to the website. So if I were to download one by one each of those speeches, maybe copy and paste the speech, create a file name on my computer, save it there, then go to the next speech, copy and paste the text, create a file name on my computer, save it, etc. It would take me weeks and weeks of work. So I want to avoid this. So instead, what we do is we write a little program, maybe in Python, that automatically goes to the website, downloads the file, and goes to the next page and downloads the file, etc. The computer can do it in no time. Some technical complications. The Kremlin website does detect that a program is in rapid pace trying to download too much, so it blocks this, so you have to trick it a little bit, make it think it's a human. But that's just a technicality. The basic point is we can write a computer program to take steps that are for a human really too mundane, too boring to do, and too repetitive. And it can do so 1,000 millions of times, and it doesn't matter, it just keeps going. Another example would be computer simulation, right? If I have a simulation and I have some model that I want to look at, so I, for example, wrote a simulation years ago about how if countries that are surrounded by democracies are more likely to become democratic themselves. And I had some assumptions when that might happen, when that might not happen. Then I wrote a computer program to implement those steps. And you have some findings right away, but you want to know whether those findings hold in many different circumstances. So I wanted to run the simulation thousands of times. If I write a computer program to do it, I can just press a button to start, I can wait a day or two, and then I can see all the output from all these simulations. If I had to do it manually, it would take forever, and we wouldn't do it. So there are different social science applications where we can write computer programs to simplify tasks, either because they are very mundane, or because they contain a lot of complicated computations that are too difficult to manage by yourself. And it can handle very large amounts of data. It can work with, if we download millions of tweets and we want to study them and look at patterns in them, we can write computer programs to analyze those tweets. We could not manually read millions of tweets and say something sensible about it. One important distinction here is that between a computer program and just some commands that we type that are immediately executed. So in Python, there are two ways of starting Python. One way is to open the interpreter, and you can type a command and see the outcome of that command. This is very useful if you are familiarizing yourself with some Python commands, because you immediately see what they do. And so it's helpful to understand Python. It is not helpful to do any major task, because for that you need more complicated code that is not immediately performed, but that can interact with each other. And then we write a computer program. A computer program is a plain text file or a set of plain text files that contain all the commands we want to execute. And then we can pass it on to Python to say, now execute all those files. And Python will run. So here's an example. On the left, you will see the interpreter. And you will see how we can type commands and then look at the outcome. On the right, you see a Python program. And that looks more like just a text file. Now, don't worry about the code on the left is code that we study for this week. Code on the right contains lots of code that only occur in the coming weeks. So don't worry that you can't follow all the Python code on the right. It is just to show you what a Python program looks like. In this video, I want to show you some first steps in Python. So on my Mac, I can start Python from the command prompt. We will see later how that works exactly in Windows and other systems, but for now, let's assume we can do this. So the first thing I can do is just call Python and ask for the version number, just to check that you have the right version. So Python has different versions, and there's especially a particularly big difference between Python version 2 and Python version 3. So it's very important that you use Python version 3, and that preferably something more recent than Python 3.4. So here I use Python 3.5.5. Now we can use Python in two different ways. We can use what is called an interpreter. An interpreter means a system where I can type commands, and those commands are immediately evaluated. So when I type a command here, it will immediately provide some output. If I just type a number, it will just return that number, for example. This is not how we use Python most of the time. So this is nice, interactive, and it's very helpful to quickly experiment how a particular command works. So I might have a very simple idea, and I just want to quickly check whether I understand the command correctly or not. And this is a very good system to use, the interpreter. Normally, however, we use Python differently. We will have text files that contain all the commands we want to run, and then when we start Python, we give it immediately that file and run that file. So normally, it will run all the commands in a sequence in a particular Python file. And that is how we are going to use Python throughout the course. But for the very first steps in Python, the interpreter is easier, because you can immediately see what is being done. So here I've showed the number 5, for example. I can also add text if I want. Text is always between quotation marks. We will talk a little bit more about text in detail later. Any computer program, and also anything we type in here, consists of a set of statements. A statement can be just a number or a string of text. A statement can be a simple computation, or a statement can be something more complex. So a computer program is just one long series of statements that are organized in a certain way. And to show you a little bit how statements work, we will use Python in the most simple form, which is as a basic calculator. So we will look at just numbers. I'm going to ignore text for today. And we will look at how you can calculate with numbers in Python. So the most simple calculation you'll probably remember from already primary school or kindergarten maybe, is just addition. So we can add two numbers together and get the sum. And in Python, we do that with a plus sign. So 2 plus 7 is 9. So you can see the statement, which is 2 plus 7, and you can see the result, which is the 9. So in a computer program, you would normally not do this. You don't want to work with output like this. This works in the interpreter. So in the interpreter, we can type a command and immediately see the output. In a program, we would normally save the output and then think about how we would present this to the user. So we can use any kinds of numbers, of course. We can use plus and minus. We can use negative numbers, of course. So this is relatively straightforward. So addition and subtraction, we just use the plus and the minus sign. We can, of course, also multiply or divide. If you want to multiply two numbers, we use the asterisk symbol. If you want to divide, it gets a little bit more complicated. So for the asterisk is multiplication. For division, we use a slash. So this gives an obvious answer. But you will also notice that it put this 0.0 behind the 8, and that means that the type has actually changed. So we will talk about types next week, so I won't go into that. But the type has changed from what is called integers to floating point numbers. But we'll get to that later. So we can also do, so 16 can be divided by 2, right? And we get a rounded number. We can also divide by something that is not a proper divisor, and then we get this decimal point. Now in Python there are two ways to divide. There is a second way to divide, which is to use double slashes. And if we do that with a 2, it has no difference in the result. But if we do that with the 5, we do. But we also see that not only has it rounded the number, so 3.2 became 3, it also now keeps the type integer instead of floating point. So 16 and 2, they are integers. 8 is also an integer, but 8.0 is a floating point number. So I will talk about that next week. You don't need to worry about that. But you do need to understand that there are two kinds of divisors. There's the single slash, which does not round and leaves everything behind the decimal point. And there's the double slash, which does round and removes everything after the decimal point. And it should be emphasized that this is not proper rounding, but just cutting off everything behind the decimal point. So, for example, if we have 8 divided by 5, we get 1.6. If you would be in a physics or statistics class and you want to round this number, it becomes 2. However, here, if we use double slash, it becomes 1. So it just truncates. It takes off everything behind the decimal point. We can also look at slightly more complicated maths. So the most important that I have not yet mentioned is the power. So we can say 2 to the power of 5, for example. And in Python, that is done with 2 asterisks. So 2 times 2 times 2 times 2 times 2 is 32. Yeah, so this is the same as this. Yeah. So 2 and then double asterisk 5 means 2 to the power of 5. And finally, we can of course make more complex numbers, and here the parentheses are particularly important, just like when you write a mathematical function. So there's a difference between 2 plus 2 times 5, where you get 12 because the multiplication has precedence over the addition. So you get 2 times 5 equals 10, and then we add 2, versus 2 plus 2 times 5, which is 4 times 5. which is 20. So I won't go into more detail in all these precedence rules because I just wanted to show you how you can use Python as a calculator. But it's important to know that these precedence rules are there. And they follow the standard convention in mathematics. So when you write a mathematical equation, it is the norm that multiplications are done before addition and subtraction. And that is the same in Python. So here you can see the basics of using statements in Python, the basics of using the interpreter, and you can see how to do basic calculations such as plus, minus, multiplication, division, and division with truncation. Okay, so I've shown how you can use the Python interpreter for basic calculations, adding numbers, subtracting, multiplication, division, and slightly more complicated expressions where you use parentheses to clarify the order in which calculations should take place. This is a very basic use of Python, but you will see that calculations often occur in computer programs. The computer is not, by coincidence, named computer, of course, which means to calculate. So this is a really core functionality of what a computer program can do. The rest of Python coding we will learn over the next weeks. But there is one very basic command, your very first command in Python that I want to teach you, the print command, which is a command to print some input that you give to this function to the screen. And that is a way that we can show the outcome of whatever calculation or data manipulation or whatever we do to the user of the computer program. So it's a crucially important feature. It's nice if the computer program can calculate a lot of things or manipulate a lot of data. If we cannot then display this data or save the data, then it is all pointless. So this very first command shows you how to type a command in Python, how to see the output, and it teaches you the first command, the print command. So the function I want to show you is the print command. So with print, we can put something on the screen. So if I put print 5, it will show a 5. So print means to put something on the screen. Or in computer language, this is called standard output. But standard output is normally the screen. That's where it is placed. So I can print numbers, I can print the outcome of some computation, and I can also print text. Okay, so we can type anything here that we want to print, and it will show on the screen. Now you will have seen that in the interpreter, just typing 5 has exactly the same effect as print 5, but that is only true in the interpreter. So normally when we write computer programs, it is the print command that we will be using. We will not be just typing a number or just typing a string of text. So in the interpreter, you can just type any number or string or any other kind of object. And Python, the interpreter is programmed in such a way that it will always evaluate the statements that you type in and then print the output. So implicitly, behind the scenes, there is a print command there, but you don't need to type it. And if you look at the overview of commands that we learn each week, in that environment, I also did not need to explicitly use the print command, so it is often omitted. But when we write a computer program, which you will be doing throughout the course, then you will always need the print command to put anything on the screen. So this is the first important command to learn in Python. And notice a little bit how we do this. So we have the name of the function first, print, then we have parentheses, and then we pass on what we want to print. So print parentheses 5 means that we want to print 5. And print parentheses, quotation marks, and some text, it means that we want to print that text. So here you have learned the first Python command, print.